Hi everybody. To briefly recap where we are, we're trying to come up with a formula for the average value of a function on an interval. We've approximated it by taking the average of n function values, and now we're going to take the limit of that average as n goes to infinity. In order to calculate this limit, we need to turn it into a definite integral. And to do that, we said we needed to get delta x into our formula. What is delta x? Delta x was the width of each rectangle. What would that be in this case? We got our rectangles by taking the interval from a to b and dividing it up into n rectangles of equal width. So the width of each rectangle must be the total width from a to b, which would be b minus a, divided by the n rectangles. How does that help us? Well, in the formula we've got so far, we do have an n. So if I take that delta x formula and solve it for n, we'll get an expression for n that has a delta x in it that we can put in for this n. So let's do that. If I multiply both sides of this equation by n and then divide by delta x, I have n equals b minus a over delta x. Now what we actually have in our formula is 1 over n. In other words, the reciprocal of n. Let's just go ahead right here and realize that the reciprocal of n would be delta x over b minus a. Putting in what we've got so far then, we have the limit as n goes to infinity of delta x over b minus a times the sum as I goes from 1 to n of f of x sub I star. And I see I need to change these dots in our formulas to stars because, as I mentioned in the last video, my equation editor is not wanting to do that. We're just going to do two little things to clean this up so that it can turn into the definite integral. Let's distribute this delta x into our sum. And when you distribute into a sum, each term gets multiplied. And b minus a is just a constant. 1 over b minus a is just a constant. It's whatever numerical value you get there, because b and a are constants. You decide on them before you launch into this whole procedure. So that can be pulled out to the front of the limit. And now we have 1 over b minus a times the limit as n goes to infinity of the sum as I goes from 1 to n of f of x sub I star times delta x. This limit of the sum is exactly what we define to be the definite integral. So what we're getting here is 1 over b minus a times the integral from a to b of f of x dx. In other words, our final formula for the average value of a function on the interval from a to b is 1 over b minus a times the definite integral from a to b of f of x dx. In the next video, I'll go over an example with you.